back to Dr. Ray class. Today we're going to solve this problem on electricity. As you know, electricity is one of the most important and common topics in physics, and every exam you go, you'll see something to answer from electricity. To some learners, this might be difficult, while to some, this is simple. What we're going to do is try as much as possible to make it easier for those who are finding this kind of question difficult to solve. The question says, find the PD across the 4 ohms resistor. Now here is the circuit. You have the cell with EMF 3 volts. And you have 3 resistors connected in series. The first one is 3 ohms, second one 4 ohms, the third one 5 ohms. So what I'm going to do is, I am going to put little expressions here. Say this is the total voltage in the circuit. That means the total strength of the electricity coming from this cell. The total strength is 3 volts. I'm going to represent it with V. This 3 ohm resistor, I'm going to represent it as resistor 3. The 4 ohms, I will call it resistor 4. And the 5 ohms resistor, I will call it resistor 5. It doesn't matter the symbol you are using. I chose to use the same, their values to identify them. The first thing you ask yourself is, I know the total voltage in this circuit. Do I know the total current in the circuit? No, I do not. Do I know the total resistance in the circuit so that I can easily apply Ohm's law? No, I do not know the total or effective resistance in the circuit. But I can do it. Why? I have the individual resistances in the circuit. Since I've realized that, I say, okay, the resistances in the circuit, how are they arranged? Is it in series? That means on a straight line, side by side, or in parallel, that means hand in hand. And of course, there's only one path for electricity to pass in this circuit, telling us this is series resistance. And of course, you remember the total resistance. So the total resistance in the circuit, I'm going to use capital R to show the total. Since they are in series, we simply add the first one R3, the second one R4, the third one R5. Now the total resistance is, the first one is 3 ohms plus 4 ohms plus 5 ohms. So the total resistance is 12 ohms. Now you remember from Ohm's law, right? We have the formula for voltage as IR. Here, this is my total voltage, this is my total current, and this is my total resistance. I have my total voltage as 3. I have my total resistance as 12. So I can easily make my current total the subject of the formula. Dividing both sides by R. So I have my total current as total voltage divided by total resistance. What is my total voltage? 3. What is my total resistance? 12. 3 divided itself 1. 3 divided 4. 12 rather 4. So 1 over 4 amps is the total current of 0.25 amps. Now this is not what we're asked to, but there's a reason why we need to find it. Since we know the total voltage, we have found the total resistance. So it's important that we find the total current and keep it. Now the question is, how much voltage is required to push current across only the 4 ohms? Now I'm going to put this value of total current as 1 over 4 or 0.25 amps here. Now we have total voltage, total current, total resistance. There's something we need to figure out. When resistances are in series, there's only one path, one electric or wire path for current to pass. So that means the current that passes through the 3 ohms resistor, when it crosses, there's only one way for it to pass. That same current will pass through the 4 ohms. When the energy from here pushes the electrons cross, there's only one path for the current to pass until it passes the 5 ohms. Meaning the same current that passes through the 3 ohm resistor is the same current that will pass through the 4 ohm resistor. It is the same current that will pass through the 5 ohms resistor, and that is the total current in the circuit. Now, to find the voltage across the 4 ohms, you look at the values of the resistances, they are not equal. That means this is a higher resistance followed by this, and this is the least resistance. It means the strength of this voltage when it comes to pass electric current across these resistances, there will be more of that strength for the 5 ohms, that is V5, then followed by V4, and the last one V3. So this strength of the electricity, 3 volts, when it comes to pass the current across these 3 resistances, most of these 3 volts strength will be required to pass current here. Another value out of these 3 will be used to pass current here. The least amount out of these 3 will be used to pass current here. So they will have different voltage drops. What that means is, if you add the strength of the 3 volts required to pass current across the 3 ohm resistor plus the strength of the voltage required to pass current across the 4 ohm resistor plus the strength required to pass current across the 5 ohm resistor, when you add the 3 of them, it will give you the total strength of the electricity, which is 3 volts. From Ohm's law again, voltage is always I R. That means V4 we are looking for has to be I4, that means the current passing through the 4 ohm resistor multiplied by the 4 ohm resistor. So V4 is, we know that the current across the 4 ohm resistor is the same thing as the total current in the circuit. So we replace I4 with total current I. So what we can easily do here is substitute. Our total current was 1/4 times R4 is 4 ohms. 4 ohms over 1. This 1 times 1 is 1 divided by 1 is 1 volts. So that is the voltage, the strength of the voltage required to pass current across the 4 ohm resistor. And this is what we're asked to find. Now, just to help make sure you are correct and you trust what you are doing, use the same formula to find, or the same pattern to find the strength of voltage required to pass current across the 3 ohm resistor. So this is something as I R3, which is 1/4 times 3. This will give you 3/4 or 0.75 volts. The same way, V5 will give you I5 R5, which is I R5, 1/4 times 5/1. This is 5/4 or 1.25 volts. Now, test if this formula is correct. V3 is 0.75, V4 is 1, V4 is 1.25. When you add these 3 to give you 3 volts, which is what we started with. So telling us that concept we adopted is actually correct. And with this, we're able to analyze simple circuits like this. Don't forget, we are only asked to find